Hi, I'm Austin Hall, an application engineer here at Tektronix. Today I'd like to talk to you about Tektronix's new power rail probe, the TPR4000. The TPR4000 is a 4 GHz power rail probe, which will also come in a 1 GHz model that goes up to 60 volts in offset, both plus and minus. There's a plus or minus 1 volt dynamic range, and we'll see in a moment the noise spec for the TPR4000. First, I want to compare the baseline noise of the probe and the scope. As mentioned earlier, I want to take a look at the noise specs of the probe. Channel 1 is the probe plus the scope with the input shorted. Channel 2 is the scope with an open input. I've set both channels to 1.3 millivolts per div and set a 20 megahertz bandwidth limit, typical for power measurements. We can see channel 2 is set the same way. As you can see, channel 1 here has a peak-to-peak of around 172 microvolts max, with a mean of 107 microvolts. Channel 2, the scope open, has a peak-to-peak of around 77 microvolts mean and a max of 92 microvolts. This probe, when paired with the 6 series MSO, provides the lowest noise solution for measuring DC power rails. We offer a number of accessories for the probe to make connecting to your DUT easier. A cable with an SMA on one end to connect to the probe, and an MMCX connector on the other to connect to the accessories is provided. There's also an additional high-temp cable that is 2 meters long instead of the standard 1.3 meters for use in test chambers. For tip accessories, we have 2 soldering options. One is a micro coax that can be used to solder to small components, and another is a small paddle style that can be used to connect with lead wires across components. All accessories will click on to the cable and are easy to remove. Lastly, for click-in connectors, we have U.FL. This is common in mobile applications. The cable and solder-in accessories are rated to 4 GHz. The U.FL connector is rated to around 2.5 GHz. When you need to touch your circuit, you can use our browser. It has a pogo tip on one end with various options for connecting your ground, either a long alligator clip or a short spring ground. Additionally, we have square pin adapters and capacitor clips to connect to small components. The browser is rated to 1 GHz, with additional accessories being derated. Now let's look at a real signal. I have a small single board computer with an SoC and some fast memory. I'm connected across a decoupling cap for the 3.3 bulk line. To 3.3 volts. We're first going to make a 4 GHz measurement. I'll adjust my scale and my horizontal scale. Now I can crank my sensitivity. Position the waveform on here. Adjust my trigger, and take a single acquisition. Now let's zoom in. I can see some fine detail and some high frequency noise on this waveform. If we first zoom in and take a look at the frequency of the rising edge, we can do so adding cursors. This is around a 1.2 megahertz frequency right here. This correlates to one of the switchers on the board. We can also take a look at a 20 megahertz measurement, and we can see the high frequency noise goes away. Now coming in, we can change our cursors and look at an amplitude. Smallest detail we can see on here is around 4 millivolts. Now let's take a look at the falling edge. We can see some detail here We'd like to investigate a little further. Let's take cursor B, move it over here, and cursor A and do the same. Going to zoom in on this. We're going to do the same activity we did before. Rough frequency estimate gives around 2 megahertz. Again, if we do a vertical measurement, we can make a 437 microvolt distinction on this pulse right here. Using this probe along with the 6 series MSO provides incredible detail into your design. Thank you for taking the time to look at the Power Roll probe with me today. If you have more questions, please contact your local account manager.